Motion of a block on a rough inclined plane. Objective: to determine the conditions for motion of a body on a rough inclined plane. A block of mass m is placed on a rough plank, whose coefficient of static friction and coefficient of kinetic friction are μs and μk respectively. The angle of inclination of the plank, theta, can be varied. Let the angle of inclination be increased gradually. Accordingly, static friction acting up the inclined plane increases to balance out the increasing gravitational pull down the plane. At a certain angle, the static friction reaches its maximum, and the block becomes poised to slide down. For any angle greater than this angle, block slides down. This angle, alpha, is known as the angle of repose. Draw the free body diagram of the block when angle of inclination is equal to angle of repose. Take x and y axes along the direction of inclined plane and perpendicular to it, respectively. The normal reaction N acts along the y-axis. The components of the gravitational force are mg sine alpha along x-axis and mg cos alpha along negative y-axis. Normal reaction N is balanced with mg cos alpha. Static friction reaches its limit at the angle of repose. We know that limiting friction is equal to product of coefficient of static friction and normal force. That is, static friction acting up the inclined plane is equal to μs mg cos alpha. As the block is at rest, static friction should be equal to gravitational pull down the plane, mg sine alpha. Thus, mg sine alpha is equal to μs mg cos alpha. So, tan alpha equals to μs. Therefore, angle of repose alpha equals to tan inverse of μs. If the angle of inclination theta is less than the angle of repose alpha, the block remains at rest. Static friction acts on the block, and it balances the x component of the gravitation force mg sine theta. Therefore, Fs equals to mg sine theta. If the angle of inclination of the plane, theta, is more than the angle of repose, alpha, the block starts to slide, and kinetic friction starts acting on it. The kinetic friction is equal to the product of coefficient of kinetic friction, μk, and normal reaction force, N. Normal reaction N is balanced with mg cos theta. Hence, kinetic friction opposite to the motion of block is μk mg cos theta. Resultant force on the block is mg sin theta minus mu k mg cos theta down the inclined plane. Acceleration of the block down the inclined plane is equal to net force divided by mass of the block, which gives A equals to g sin theta minus mu k cos theta. Summary: if the angle of inclination is less than the angle of repose, the static friction acts and is equal to mg sin theta. If the angle of inclination is equal to the angle of repose, limiting friction acts and is equal to mg sin alpha. If the angle of inclination is greater than the angle of repose, kinetic friction acts and is equal to mu k mg cos theta. Acceleration of the block